Hello guys, welcome back to your physics class. Hope you are all doing well. I'm back again with another video lesson. If you remember, in a previous lesson, we studied buoyant force in chapter 3, section 1. Buoyant force is an upward force that exerted by a fluid exerted on an object. So its direction is always upward in opposite direction of the gravitational force. So the buoyant force exerted by the fluid, so the fluid may be gas or liquid. Okay, so the object, like for example, when does the object submerge and when does the object float and when does the object suspend in the water, it depends on the density and the amount of the buoyant force. We stop it here in section the questions of the section review. Question 1, what is the difference between solid and fluid, and what is the difference between gas and liquid? The difference between solid and fluid, a solid has a definite shape while a fluid does not. So the difference between fluid and the solid is in the shape. Solid has definite shape while fluid does not. So how about the difference between gas and liquid? Liquid has a definite volume while gas doesn't. So the difference between gas and liquid is in the volume. Liquid has definite volume, but gas doesn't. Okay. Question 2, which of the following object will float in the tub of mercury? To determine which object float in the tub of mercury, what is the type of the fluid here? Is mercury. Okay, so you have to know. And if I bring this question in the exam, I will give you the table of the densities, like as you can see in this table. Okay, don't worry, for this question the teacher must give you this table. Okay, the table of the densities of some common substances. The density of a mercury is, this is density of mercury, is equal to what? Is equal to 13.6 times 10 power 3. Okay, 13.6 times 10 power 3. So the density of gold is 19.3 times 10 power 3. This is kilogram per meter cube, and this is kilogram per meter cube. B, I think the second substance is, guys, look, we have solid gold, ice cube, iron bolt, and 5 milliliter of water. Ice cube, iron bolt. So now we have to write down the density for the ice cube. Look. Okay. The density of the ice cube is 0.90 times 917 kilogram per meter cube, and the density of iron bolt is 7.86 times 10 power 3 kilogram per meter cube. So the last one, the density of water, which is equal to 1 times 10 power 3 kilogram per meter cube. Let's go back to the question. This is question 2 in section review. Guys, for this question, you are not required to memorize all the densities for these different substances. Okay. In this case, if your teacher brings this question in the exam, so this table, the table of the density of the substance, must be given. Okay. Guys, look, which of the following objects will float in a tub of mercury? To determine which object floats, you have to compare with the density. Okay. So which one is bigger? The density of gold or density of mercury? Absolutely, the density of gold is bigger than, look, the density of gold bigger than the density of mercury. So that is why the gold sinks. Okay. Why the gold sinks in the top of Mercury? Because the density of gold is bigger than or more than the density of Mercury. When does the object sinks or submerge in a fluid? If the object is density bigger than the fluid density. Okay. Why the gold sinks or submerge in the top of Mercury? Because the density of gold bigger than the density of Mercury. Branch in B. The second substance is ice cube. Which one is bigger? 0. Sorry, here 10 power 3. 0.917 or 13.6. Which one is bigger? The density of mercury is more than the density of ice. So that is why the ice floats. Because the density of ice less than density of mercury. So that is why this one floats. Okay? And the density, the iron also float in the top of mercury. Why? Because the density of iron is less than the density of mercury. Okay? The iron bolt also floats. Okay? The iron bolt also float. B float. Iron bolt also float. 5 milliliter of water also float. Why? Because the density of the mercury is more than the density of the water. So that is why this one also float. The water is also float. Only gold sink. Okay? Or submerged. So the correct answer, because the question says which of the following float? B, C, and D, except A. Question 3. Look at this question. 650 kilogram weather balloon. A 650 kilogram weather balloon. Mass of balloon is equal to 650 kilogram. Is designed to lift a 4,600 kilogram package. Mass of package M sub P, it means that the mass of the package that can lifted by the balloon is 4,600 kilogram. Okay, we have a balloon and we have a mass of package. Okay, the mass of the persons that can like for example that can be lifted by the balloon is 4,600 kilogram. Okay, and the material that can be exist in the balloon, and the balloon can lift this mass of the material, which is equal to 4,600 kilogram. What volume should the balloon have after being inflated with the helium at 0 Celsius? What is unknown? What volume? The volume of the balloon. Okay, the volume of the balloon is unknown. Okay. After being inflated with the helium at 0 Celsius and 1 atmospheric pressure to lift the total load. We have to use the density for the helium. The density of the helium must be given in this question. Okay. And it is equal to in the table. Okay. Look at the table. The density of the helium. Guys, look. The density of helium is equal to 0.179, and the density of air, because the balloon is rising in the air, is equal to 1.29 kilogram per meter cube. Kilogram per meter cube. Okay. Now we have to determine the volume of the balloon that can hold the 4,600 kilogram. Okay. Okay, guys. Because the balloon is floating in the air. Okay. So that's why we have to use this relation. FD, the buoyant force, is equal to gravitational force. Okay. Or according to the Archimedes principle, the buoyant force is equal to the AFG, or the gravitational force of the air displacement. Okay. Buoyant force, as you know, if the buoyant force is not given, instead of buoyant force, we have to use the density of air, rho, the volume of air, and gravity. And Fg is equal to what? M, object, mass of the object times gravity. Okay? So, the density of the air, look guys, so in this case, these two gravity will cancel each other. G with G cancel. What is remain? The density of air times volume is equal to how many masses do we have? We have three mass. Okay, the mass of balloon, mass of package, and mass of helium. So we have to add up all masses. Okay, for the gravitational force, mass of balloon, mass of helium, and mass of package. Okay, so after writing the mass for each of the substance like balloon, package, and helium, do we have mass of helium? No. And instead of mass of helium, you have to write down this relation, guys. Density is equal to what? Mass per volume. The density of helium is equal to mass of helium divided by volume. Mass of helium is equal to what? Rearrange this equation. The density of helium times volume. So the volume of the air is equal to the volume of helium. Why? Because they occupied the same space at the same time. Okay? The volume of air is equal to the volume of helium. Bring down this, the density of air times volume is equal to mass of balloon, mass of helium plus, sorry. And instead of mass of helium, write down what? And instead of mass of helium, write down the density of helium times volume plus mass of package. If you arrange this equation, move this density of helium times volume to the other side, it becomes negative. What is remain here? The density of air times volume minus density of helium times volume is equal to mass of balloon plus mass of package. Okay? So how many volumes do we have? Two volumes. These two volumes are the same. So we can get one of them as a common factor. What does remain? The density of air minus density of helium times volume is equal to what? Mass of balloon plus mass of package. What is unknown? Volume. Volume is equal to uh, density of air minus density of helium over the balloon's mass plus the mass of package. Okay, so in this way you can determine the amount of the volume of the helium. Okay, what is the volume should the balloon have after being emitted? This is the volume that the balloon have after being emitted. Okay, volume is equal to what? Replace the density of air 1.29 minus density of helium 0.179 divided mass of balloon was given 650 plus 4,600. Volume is equal to what? By calculator you can get the final answer, which is equal to 4.73 times 10 power 3 meter cube. In this case, so in this way you can determine the amount of the volume that after the balloon being inflated. Okay, we do it. Question 4 in section review. A submerged submarine altered the applied to a fluid, like maybe liquid or gas. The pressure applied to a fluid in a closed container. In what? Closed container is transmitted equally to every point of the fluid and to the walls of the container. Okay? Once again, listen carefully. What is the Pascal's principle? Pascal principle stated that pressure applied to a fluid, when the pressure applied to a fluid, like the pressure applied to the air, pressure applied to the liquid, in a closed container, like a balloon, when you are trying to inflate a balloon, okay, so you press it on the air, okay, on the gas in the balloon. After inflated the balloon, what happened to the balloon? The entire balloon expanded, okay? In a closed container, is transmitted, this pressure transmitted equally to every point, okay, of the fluid and the walls of the container. This is Pascal's principle. Here are some everyday examples that explains the Pascal's principle, like a hydraulic press. This hydraulic press is very important, and by using the Pascal's principle, like for example, we can use the hydraulic lift to lift a heavy object like a car. By using a small amount of force, we can lift the heavy object like a car. Okay, how the hydraulic lift works. This is a classic example that demonstrates how force can be multiplied using a fluid. A hydraulic press consists of two pistons. How many pistons do we have? Two pistons. Okay, we have two pistons, guys. Small piston, here small piston, and large piston. Okay, two different pistons of the different sizes connected by a closed chamber filled with the fluid. So we have a fluid inside this chamber, okay? Filled with the fluid. When a small force is applied to the small piston, this is F1. What do you mean by F1? The force on the small piston. F1. What is F1? Force on small piston. Okay. When the force applied on a smaller piston on a small area, what is this? This is A1 area, small area. Create is what? A pressure increases in a fluid. This pressure is then transmitted and diminished to the large piston. This pressure, guys, P1 is transmitted equally to the second piston. So now, do we have pressure on the small piston? Yes. The pressure of the small piston is called P1. Okay. This pressure is transmitted from the small piston to the large piston inequally, okay, according to Pascal's principle. The same amount of the pressure that exerted by the F1 on a small area exerted the pressure and transmitted equally to what? To the second area, okay? And diminished to the larger piston, resulting in a much larger force on the large piston, okay? So the large force is produced here. F2, large force on a large area, okay? Exerted on A2. A2 is the large piston. A2 is what? Large piston. We have force and area. It means that there is a pressure here, P2, okay? So according to Pascal's principle, how many pressures do we have? Two pressures. P1, P2. F1 over A1 results of P1. F2 over A2 is resulted P2. So according to Pascal's principle, which one is bigger? Pressure is transmitted equally in this vacuum chamber, okay? In this chamber that filled with the fluid. In both cases, in both pistons, we have the same pressure according to Pascal's principle. Why? Because Pascal's principle states that pressure applied to a fluid in this small piston in a closed container is transmitted how? Transmitted how? Equally. What do I mean by transmitted equally? It means that P1 must be equal to P2. Okay? P1 is equal to what? Is equal to F1 over A1. How about P2? F2 over A2. So this relation is very important for solving questions. Okay? In this, by using this relation, we can determine the force on a small piston, the force on a large piston, and you can find the area. The hydraulic brake, this is the same thing, one of the application of the Pascal's principle. When you pump a bicycle tire, when you squeeze a tube of toothpaste, you are using the Pascal's principle. So we have many applications of the Pascal's principle. A hydraulic lift such that is shown in the figure to make use of a Pascal's principle. Okay, and this figure. Okay. A small force applied to small piston of area A1 causes a pressure increases in the fluid, such as oil. According to Pascal's principle, this increasing in pressure, P increases, is transmitted to the large piston of A2 and fluid exert a force F2 on this piston. Applying Pascal's principle and definition of the pressure gives the following equation. As I proved for you, P1 over P1 is equal to P2. F1 over A1 is equal to F2 over A2. Cross product. F1 times A2, cross multiplication, F1 times A2 is equal to F2 times A1. To determine the force on a small piston, F1 is equal to what we have with F1, A2. It goes to the denominator. What is remain? F2 times A1. To determine F2, A1 goes down. What is remain in denominator? F1 times A2. These two relations are very important to determine the force on a small piston. This equation can be used to determine force on a small piston. And this one can be used to determine force on a large piston. Force on what? On a large piston. F1 exerts the small force on a small area, produces P1. So this pressure transmitted equally to the second piston. In the second piston, the force F2 and A2. Okay? These two pressures are equal, but the two forces are not equal. In this case, guys, listen carefully. F2 always bigger than F1. A2 always bigger than A1. But P2 is equal to P1, same. At constant pressure, the relation between force and area is directly proportional. Okay? In a hydraulic lift, so this is classroom practice, you have to solve this question by yourself. In a hydraulic lift, 620 Newton force exerted, this is F1. The exerted force is F1. Exerted on the area, this is A1. In order to support a weight that places 2 meters square, this is A2. How much pressure exerted on the narrow piston? Sorry, this is F2, hydraulic lift, okay? This is F2, sorry. How much pressure? This is the white area. Exerted on the narrow piston. Narrow piston, it is at F1. F1 is unknown, guys. Which equation can be used to determine F1? This one. F1 is equal to what? Is equal to F2 times A1 over A2. Look. Do we have F2? Yes, 620 times A1 0.2 over 2 meters squared. Okay? 620 times 0.2 divided by 2 is equal to 62 Newton. F1 is equal to what? 62 Newton. It should be less than. the force on the second piston. Area of a circle, the area of a circle and the base of the cylinder is equal to pi r. When area is not given, guys, be careful. If the area is not given, radius or diameter must be given in the question. If the diameter is given, you have to convert this diameter to what? To radius. How? Radius is equal to diameter divided by 2. And then you have to convert this radius to what? To area. How? Area is equal to pi r squared. Okay? When diameter is given, you have to convert to radius, then you have to convert to area. Because we don't need radius and diameter. We need area to determine like the force on a small piston and a large piston. Okay. And now, sample problem 3b. A small piston of a hydraulic lift has an area. Small piston has an area. It means that A1. Sample problem 3b. Small area, a small piston, of a hydraulic lift, small piston, it means that A1, 0.2 meters squared. A car rating, 1 point. Car weight, always, guys, be careful. Car weight, it means that F2, always. The weight of the car, when the weight of the car is given, so it means that this force is F2, the force on a large piston. F2 is 1.2 times 10 power 4 Newton. Because the heavy object like a car should be placed on the large piston, and by, like for example, using a small force on a small piston, we can raising and lift the heavy car, which is the F2, and the heavier object that located on the large piston, F2. Seats on the right mounted on the large piston. The car is located on what? On where? Large piston. The large piston has an area, A2 has an area 0.9 meters squared, okay? How large a force must be applied to small piston? The force applied on a small piston is unknown. How large a force applied on a small piston? To find the F1, the force on the small piston, you have to use this relation. F1 over A1, F2 over A2. What is unknown? F1 unknown. How can you determine F1? You have to rearrange this equation. Cross product is equal to F2 times A1 over A. Do we have F2? Yes. 1.2 times 10 power 4. Do we have A1? Yes, we have it. 0.2 over 0.9. F1 should be less than F2. 2.7 times 10 power 3 Newton. Which one is bigger, F1 or F2? Absolutely F2 is bigger. Why? Because here we have 10 power 4. Okay, but this is 10 power 3. 1.2 times 10 power 4 is bigger than 2.7 times 10 power 3. It's very easy. Practice 3b, question 1. Practice Practice 3b, question 1. In a car lift, compressed air exerts a force on a piston with a radius. This is radius, okay, is 5 centimeter, which is equal to 0.05 meter. You have to convert centimeter to meter divided by 100, okay? This pressure is transmitted to the second piston with a radius. This is R1, and the radius of the second piston is equal to 15 centimeter divided by 100, 0.15 meter. This is R1 and R2, okay? How large force must the compressed air exert to lift 1.33 times 10 power 4 Newton car? This is F2. F2 1.33 times 10 power 4 Newton. How large a force must be compressed? It means that F1 is unknown. What is unknown? F1. Guys, but before solving this question, F1, look. F1 over A1 is equal to F2 over A2. F1 is equal to what? Is equal to F2 times A1 over A2. Do we have A1? No, we don't have A1. A1 is unknown, but instead of A1 we have R1. As I told you guys, when R is given you can find area. A1 is equal to what? Is equal to pi R1 squared. A1 is equal to what? Pi 3.14. 3.14 times 0.05 squared is equal to 7.85 times 10 power negative 3 meters squared. A2 is equal to what? Pi R2 squared. Pi 3.14 times 0.15 squared is equal to 0.071 meters squared. Now, after finding the two areas, we can replace F1 is equal to what? F2, 1.33 times 10 power 4. Do we have A1? We didn't have, but we found A1, 7.85 times 10 power negative 3 over A2, 0.071. Okay? 1.33 times shift log 10 power 4 times 7.85 times shift to log 10 power negative 3 is equal to something divided by 0.071, which is equal to F1 1470.5 Newton, or you can say 1.5 times 10 power 3 Newton, okay, which is smaller than F2. What pressure produces this force? This is branch A, guys. Branch B, I'm going to solve here. Branch B, what pressure produces this force? F1. P1 is unknown. Is equal to what? F1 over A1. And also you can use P2, F2 over A2. F1, 1.5 approximately times 10 power 3 over A1. We didn't have, but we found 7.85 times 10 power negative 3. This is cancelled with each other, and this pressure, sorry, not cancelled, sorry, not the same unit. Okay, this is 10 power negative 3, not cancelled, okay? It's gonna be like 1.5 times 10 power 3 divided by 7.85 times shift to log 10 power negative 3. P1 is equal to 1.91 times 10 power 5 Pascal. This is P1, okay? So in this way, you can determine the pressure produces this force, okay? Guys, that's all for today. Inshallah, in the next lesson, we are continuing explaining and solving all questions that related with the section 2 in chapter 3. Thank you for listening and keep up your wisdom.